Hey again guys, and welcome back. Slower shipping than usual, so I finally have 5 packages put together. It's time for another mailbag. First one up is this big one that I have been anticipating for quite a while. It says Pliers plus 10 jaw kit. This was $52.86, May 10th to May 25th. Oh, comes in a bag. I'm not sure if I knew this. I shopped quite a few listings to find the correct one, which was the cheapest price and the most accessories with it. So I'm quite excited about this. Haha. So this here is a crimper. Some of you may already know that I love crimpers. I've got a ton of them, and yeah, not quite enough of them actually, because I keep finding things that I cannot crimp. So I finally broke down and said, you know what, enough is enough. I'm gonna get myself a crimper kit with pretty much all of the jaws possible. So this has, I think, 10 additional jaws, so that I'll never have a crimping situation where I don't have the proper jaws for them. So yeah, this is what this is. And on top of that, I got a crimper style, which is much bigger. So these here are the ones I've had before. And these are the SN series, and they're pretty good, but this one here is the HS series, which are much bigger, as you can see, and so you can get more clamping force onto the jaws. So yeah, there's all sorts of tips that do all sorts of different things. Maybe I'll lay some out for you guys so we can see, and then maybe I'll just go pick some crimp and give them a try. So it wasn't really clear in the description if it came with 10 or 11 jaws, but it does come with 11. So it comes with the 10 replacement jaws and the ones that are in the tool itself. And this is pretty neat. I can see a couple of cool things already. So if you look at this one, and I might have to bring it up and change the focus point a little bit. There we go. Hopefully you can see that. So it's got that little kind of double bump sort of M shape on top of this die here. And if you look inside though, it is stepped. You see there's like the inner and the outer here. And so what these kinds of things are for, these are for crimps that have a section that crimps onto the wire itself, and a section that crimps onto the insulation for mechanical stability. So these are very specialized jaws. Then you've got things like this, for example, which end up in kind of a square shape. And that square shape is actually for ferrules. So you see on the inside, the jaws have this pattern here that sort of crimps the ferrule onto the bit of wire. That's pretty neat. I do have a ferrule crimper already, but that's a little bit different. And here's kind of the same thing, but for much bigger ferrules. You can do pretty big crimps with this kit, which is pretty neat. Then you've got things like these sets of jaws. So if you look at that one, so these are for like the type of crimps that don't have a relief in them, don't have 2 pieces of metal, it's just a solid cylinder. And that little piece in the middle, the little little hanging part, will go and press down hard into the middle and create a sort of crimp shape with that. And also, I thought this one's, I think there's an anvil here, this guy here at this end, for crimping, like crimping things shut. See that? Quite interesting. Either that or it's for alignment. I'm not 100% sure. You've got crimp jaws like these guys here. Same sort of deal, but this is for an insulated crimp. So you got a piece that crimps onto the wire and a piece that crimps onto the insulation, like so. And you've got something like this, which you can use for sort of like MC4 style solar connectors. So that would be one of those. And again, this guy here for the insulated crimps. And they give you a little pattern on them to verify the size. So yeah, I think this one is pretty complete. Even have the ones that are in there. Same thing, the insulated crimps. I think I'll be able to do most of the crimps that I need to, but now that I have a HS style crimper, I'll be able to buy the individual jaws that I'm missing. There's a lot of sellers that have listings for individual jaws, but never a package for all of them, because I think in this series there are probably about 60 different jaws you can get, which are very specialized. But I figured this would give me the most variety. And then the individual ones that I would need separately, I could just buy them separately. So yeah, let's try a crimp. Let's try crimping some MC4s. So I've got this jaw in here, the one with the little M shape at the top, if you can look at that. And yeah, these are still the MC4 connectors that Banggood has sent me. So see about the size we need. It's probably this the 4mm one here. 2mm? No, probably the 4. Alright, so I'm just gonna bring this in, little pinch the wings in a little bit, pop it into there. Oh, maybe it's not the 4. Well, either way, that's the one we're using. Then we've got wire. I've got a stripped end here, and the end only needs to be stripped as long as the little section here. But I figured since I use smaller wire and I had lots of issues in the Banggood video, maybe I'll fold this wire over so I get double and I get a little bit more purchase onto the crimp here. Because my wires, my 14 gauge wires are a little small for these MC4s. Anyways, here it goes. There you can see the crimp. Look at that. Beauty. Let me get you a close-up of that. So that looks crimped just fine. And the real test is if it's going to slide into its home, being one of these things. So here it goes. It should fit. I'm pretty sure the pin end goes in here. I need to refer to my video. Come on, go in. I think it will go in, it just needs a little convincing. Just because my wire isn't quite stiff. Did it click in? Can't tell. I think it is clicked in. Oh, it is. So it did click in, and now I just need to run my gland end, like so. Pop the insulator onto there, and then you tighten these down. There we go. That's one MC4. Let's do the other side here. Try to do the same thing. We're just going to bend this end over. This is really meant for a higher gauge wire. Pop that into the crimper. There we go. Pop the wire in. Crimp down. There we go. That's a much cleaner connection than I ended up with last time. And this time we can pop all this on through here if we want. And let's see if it'll go in. It should. Yep, that clipped in. Very nice. Oh, my insulator is crooked. There we go, that should do. And there we go. Those are 2 successful MC4 crimps. And the proof is in the pudding. Nice. On to the next one. Next one up is this one here. Hopefully this one goes a little bit faster than the previous one. This is an LED chip. And it's April 2nd to May 28th, $14.27. Those expensive LED chips, huh? Well, that's because there are 200 of these actually for that price. Let's see if some of you will recognize these things. Actually, maybe I need to give you a closer look. So let's do that. Oh wow, there's something happened on this guy here. Let's take one of these out so you guys can see what they are. Okay, so this is an LED, quite clearly. Oh wow, you guys need to get a lot closer. This is literally as close as I can get you without the USB microscope, just to show you how close we are. That is an X-Acto blade. So these are WS2812B LEDs. I bought 200 of these because, well, I've been designing circuit boards and I have some cool ideas for sort of electronic sculptures or, you know, electronic art. And I want to use these WS2812 LEDs on a circuit board inside some sort of electronic art. So yeah, expect a PCB soon with these things on. And you can buy these, they're relatively cheap. I mean, $14 for 200 isn't exactly free, but they're fairly cheap, and you know, I want them and I want to build with them. So here they are. These are 50 millimeters in each direction, 50 by 50, and they have a little chip inside of them. You can probably see it right there. And that chip is actually, it's actually a little microprocessor. So what you do is you give this thing power and ground. So there's 4 pins here. You see the 4 pins in the back. 1, 2, 3, 4. Wow, it's crazy how fast your brain adapts to the magnification. But you got the 4 pins there. There is some sort of way to know, because there's a little notch there, which one is pin 1. But there's power in and ground, and I think these run on 5 volts. There is a 12 volt version, but they are far more expensive. But anyways, power in and ground, and then signal in and signal out. And all the signal in and outs are wired in series. So you send like a pulse train down, and the first LED takes its instructions from that pulse train and sends the rest of the pulses on, and so on and so on and so on, all the way down the chain. I think you can have a fairly large number of these things on the same pulse train, and the only thing you need to watch out for is the voltage drop on the power and ground lines, because they're going to be pretty long, right? So usually you get these in strips, and the strips are usually, you start losing voltage towards the end, especially at 5 volts. That's why the 12 volt versions are better, but I think for electronic sculptures, I think the 5 volt version are the best. I don't really have anything set up to drive these, but I will do a tutorial on driving these in the upcoming weeks, so get subscribed for that. But for now, on to the next one. Next one up is this one here, which is a Camel Arm 1272BK. This was $5.85. Their stuff is getting quite expensive. The little things that used to be extremely cheap from China are getting very expensive because of the shipping. This thing was probably about half was shipping, but I need this, so there we go. April 2nd to May 6th. And what is a Camel Arm? Wow, I really did only order one. I really should have ordered a few. This is a Camel Arm. Let me explain. Some of my viewers remember these things from a previous mailbag. This is a servo. Actually, it's a fairly large servo. This here is the arm that goes on top. And then you put a little screw in there, and then it, it makes your motion. The servos come with these arms. So here's a whole bag of them, and you can see there's an assortment of arms that it comes with. However, this one here is made out of aluminum. These are generally plastic, and they're quite flexible, and they snap. These guys are a lot stronger, which is a good and a bad thing. It's a good thing because if you rely on this to hold your thing together, then you're going to want something metal. But it's a bad thing because if this stays structurally sound and the part that you're bolting to it isn't, then you have problems. So this here is for the front of the snow speeder. Let me go grab that and I'll show you where it goes. The snow speeder is way too big for my work area, but this is the front steering of the snow speeder. That's the plastic arm that kept breaking on my testing. And so this arm will go right there and replace that. That'll be a nice stopgap. It'll stop this thing from breaking all the time while I figure out a new sort of steering mechanism for it. So that's what that's for. And that's why I paid so much money for it, because if I need this up and working right now, I have one in stock. I'll probably try to find a cheaper source and get a couple of them for future projects. But yeah, for now I needed a quick solution. So I found one, but I think the long-term plan will be to design some better steering. So yeah, nothing too special in this one. Let's go on to the next one. Next one up is this one here, 2 quantity nut. And January 26th, this was ordered, arrived May 7th, so that's a long time. February, March, April, May, yeah, 3 months or so. $7.23, and in fact now it's late May, so I don't even remember what this is. Oh, I do remember what this is. Neat, but I need to get some props. So for the large 3D printer build, I got this super fine rod here, threaded rod. I think it's a 1mm pitch, so every rotation of the rod moves 1mm. And these are the little brass nuts that came with it. So perfectly serviceable, but the only thing is, I don't know if you can see that, there is quite a bit of play. And because these rods are such fine pitch, usually 3D printers don't use a fine pitch like this. I just wanted it because it's going to be my precision machine, and it doesn't really matter how long it takes to move up and down the Z-axis. So because, these rods are so special, I had to special order some of these things, which are same thing as this. They're a nut, as you can see, but these are anti-backlash. They have more than one piece. They have 2 pieces that fit in like so, and there's a spring that fits in between them. So it goes sort of like this, and that forces these 2 halves apart, and that means that you get less play on the rod. So I'm going to stuff them together like this. I'm going to run one side in. Actually, you know what? I'll just run this side in first. So this is the correct thread, the 1mm pitch. and it's not threaded up past here. You just jam this guy in and thread this in, and hopefully I will get low or no backlash in this system. Let's see. Still a little bit. We can tighten this up by simply unthreading it, squeezing it together, and threading it back in. Okay, it's now loose. Shove it as tight as I can together, because the fewer threads in between the two, the harder the spring becomes. There we go. It's all the way in. Oh, it's making a nice little screeching sound. I don't know if you guys can hear that. There we go. Far less backlash on there. There's more movement in my fingers than on the nut. So it's just the same thing as this, but it's upgraded in order to have less backlash. So yeah, I felt like if I'm going all the way with my printer and making a a nice precision sort of fit, I might as well increase the quality of these things. Now, the only way to get less backlash is to use ball screws. Ball screws are a little bit more fancy, but I think for the Z-axis, just the up-down, I don't think it's necessary. I would use the ball screws if I was controlling the X and Y axis with lead screws, which I am not. I'm going to be using belts and pulleys. So yeah, these things, quite common if you have a standard 3D printer, but if you want these really fancy threaded rods, you're going to need to get these things special ordered. And that's why it took so long, because there's only a couple sellers that sell these things on AliExpress in the pitch I needed. So yeah, I got a pair of these, got a pair of these guys, and if I wanted to get some more, I'll have to special order them way ahead of time. So yeah, on to the last one. And the final item for today is this one, integrated circuits. I'm trying to remember what this is. Oh yeah, I got it early this month too, April 2nd to May 7th. So who knows what the hell's in here. It doesn't even have to be integrated circuits, really. Oh, I actually do remember now. Actually, this took quite a while. So these are basically battery management circuits for lithium-ion batteries. Let me zoom you in a little bit. So yeah, this is a BMS. Basically, it says it can handle 60 amps out. I assume these guys are all the output MOSFETs. So what this thing does is it checks the individual. Well, first of all, it does everything. Let's just put it this way: it does everything. So when you want to charge this thing, you put voltage in here and here, and these guys here, I believe these are 3 MOSFETs here. Actually, it looks like there's 6 MOSFETs. Well, anyways, you have 3 cells in series, and this will charge the individual cells, and I do believe it'll discharge them as well. If one gets too high, it'll balance them properly. And you can pull off this end, you can pull up to 60 amps. I don't know if I believe it'll do 60 amps, but anyways, it says you'll pull 60 amps out through here, and that's controlled by these MOSFETs, or switched by these MOSFETs. So if you look, the discharge path has quite a bit of current handling capability. It's kind of thick. And so, yeah, this thing will do overcurrent protection. It'll do over discharge, overcharge. It does all this stuff all in one. So basically, like laptop packs and stuff like that, they'll have BMSs like this. They're fairly cheap. I think it was $10. Yeah, $10 for 3 of these. And so I actually got some cells from a viewer that are supposedly not great, but it doesn't matter. I'll try to put together a pack using this thing and see how well it works. We're going to do charge tests, discharge tests, all this stuff with these boards. So I figured they're good to have around. You do have to match them to their chemistry. They're not programmable. So this one is for lithium ion batteries. You could probably do lithium polymer with them as well, but you cannot do lithium iron phosphate, for example, which is the big sort of battery that once I get a little bit more revenue through the channel, I want to get a relatively large lithium iron phosphate battery pack and run my entire channel, like the lighting that you see on both sides and stuff, through all the solar energy. So until I can get those bought, though, it's going to be just experimenting with little circuit boards like this. So yeah, quite interesting. I even see a diode here. It probably is for reverse polarity protection. And yeah, we're going to build a pack and see how well it works. That should be pretty neat. This is revision 2.3 of whatever the hell all this says. And so all these items make up today's other pile of gadgets. Thanks for watching, and especially thank you to my Patreon patrons for their support. It's that extra little bit of money I get every month that I can buy these things with. I have slowed down spending quite a bit because channel expenses have been through the roof. So these mailbags will be a little bit less common, but at the same time, I get people reaching out to me wanting to send me stuff, so maybe that will be able to supplement it. If you want to see the channel grow and you don't want to spend money, which I don't blame you, make sure you share the videos you like with the friends that you think will be interested. And for everyone else, thanks for watching.